see the screen? All right. Chapter 17 is functions. So in the test session, we're going to take the functions related questions from your Haese book. Yeah. So here we have first question. Graph coordinates is also given to us. 5 hockey clubs were surveyed to find the average number of hours of general fitness training their players did, the number of injuries to their players during a session. So we need to identify here what are my variables. What is my input variable? What is my output variable here? What is my independent variable and what is the dependent variable? What is independent variable? So independent variable is technically always on my x-axis. So I can see what is the name of the x-axis they have written. What they have written? Average hours of fitness training. That would be my independent variable. And what is my dependent variable? Yes, the number of injuries. Number of injuries. Which club had the lowest number of injuries? Lowest number of injuries. The lowest Y value. E. Club E. Which club's player did the lowest number of hours of fitness training? Lowest numbers of hours of fitness training. Club A. Write a sentence describing the general trend of the graph. What would be your words for the graph that you see? The graph that you see. How you define that in words? It is not linear, I think. We can say in other way, uh, like what is the connection between independent and dependent variable? Yeah, it is like inversely proportional. I can say that, but in more general words, my word would be chances of injuries become more when number of hours of fitness. No. That would be other thing. So we can say that when the hours of fitness trainings are more, then chances of injuring is less. Right. Isn't it? So Less hours of practice causes more injuries to player, isn't it? The more you train, that causes less number of injuries, isn't it? So we can write that chances of injuries of players increases when they devote less number of hours in fitness training. This could be one of the wording. If you think better than that, you can write, but this is something that we can write. Right? So it gives me idea that if you devote less number of hours of fitness training, the chances of injuries become higher on that note. Right. So it's completely depend on your own understanding regarding this connection between these two variables. Okay. Coming to domain and range of these parabolas, I can see these are parabolas. These graphs are of function quadratic. So when you solve the quadratic, generally you find the graphs are like this. Specifically, it is concave up parabola. Talking about the domain, which is all possible x value, all possible x value. So I can see here, do we have any restrictions while taking any x value? I can see I can take any x value for this graph and I have the y value for it, and it is going infinite to negative infinite. From negative infinite to positive infinite, I can get the value of y for any x here. So I can say that x is such that x belongs to real number. Or you can write in other word, negative infinite to positive infinite. Negative infinite to positive infinite. All are domain here. For the range is all possible y value. All possible y value. But when I look into the graph, I can see the graph is not going beyond negative 2. I can see the graph is coming from negative infinite, let's say, and it's coming down, and at y is equal to negative 2, at y is equal to negative 2, it turns from there and again take the same all y values that this graph had taken before negative 2. So it means that y here such that y is only greater than equal to negative 2. Of course, y also belongs to real number. This is my range. Or in other word, I can say that close bracket minus 2, comma, till infinite, open bracket. This is my range for graph A. because I can see the graph is going up, and you can see these parameters on the y. I can't know where it will going to stop. So assuming that it will go to till very much higher value, which I'm considering infinite, isn't it? It's going up, and there is no foundation to going up. So there is no restriction over going up, whether it will stop at 100 or 200 or 300 or 1 million or 10 million. It is going up. Graph B, the other kind of parabola. This parabola equation, if you want to write the equation of this parabola, this is x is equal to y square. This parabola equation is x is equal to y square. Generally we know y is equal to x square, that we have learned, but this parabola is tilted on x-axis, along the x-axis, and I can see this parabola have no x value which is negative. I can't see any x value on the left side of the parabola. So for the domain of this kind of parabola, I can write x such that x is greater than 0, because this parabola is also not taking 0. I can see this is hollow. This is not filled. If this is filled, then I can say that this is taking 0, but I think this is also not taking 0, so it's only greater than 0. Of course, x belongs to real number. Or I can write in open bracket 0 till positive infinite. While the range of this parabola is all real number. I can see this graph is going down till infinite, going up till infinite. So it will going to take all the y values. Of course, except 0, this one. So y is such that y belongs to all real number except y not equal to 0. Are you getting this? All right, let's come to next set of questions. Question 3 is, I think, quite easier for you to find the value at a specific input. Question 4 is also similar. Do that, let me know the answers. Mm-hmm. Mm-hmm. -2. Let me check. So 3 times -1 is -3 minus -1 squared is +1. So negative, positive, again negative. So it should be -4 instead. -4. Yeah. So what I'm telling, but there is this minus outside. This -1 will become positive when I squared it, and after that it again become negative. Are you getting the story? So it become positive, but due to the minus again outside, it become negative then. I think it should be negative x square plus 9x minus 18. All the things are correct, but the sign of x square should be negative. All right. Come to number 4. Mm-hmm. Okay. Okay. Yeah. So when you solve that for the zero, what would be the x value? Either x would be negative 5 or x would be positive 3, isn't it? The two factors that you got is x plus 5, x minus 3 equal to 0. So when you solve the factors individually for 0, you will going to get minus 5 and positive 3. These are the x values. Okay. Mhm. The second one can't be a function. Yes, your answer is very much right. And can you give the reason for that also? Why the second one is not a function? It's not that reason. The concept behind is to check the given graph is function or not, we use vertical line test. Vertical line test. What is the vertical line test? So you draw the vertical line to the graph at any point. It's like inspection, like food department do to go to the different restaurant and check whether the quality of the food is good or not. So you become here that inspector who check the given graph whether it is functional or not by drawing vertical line at any point on the graph, and check whether that vertical line crosses that curve at only one point at a time. If your answer is yes, it is crossing only one point at a time, then yes, that is the function. Now, if I check the second one, it's become a suspicious at 2, but it pass at 2 because we can see at 2 it taking the value 4, not 2. But when I check at 4, it fails here. Why? Because at x is equal to 4, the y value is 4 and 6 both. You can see at x is equal to 4, the y value is 4 as well as 6. So vertical line test fail here in B. It means B is not a function. Okay. Alright, let's comes to another type of question, number 10. Find the coordinate of point of intersection of the graph with given equation. we will going to learn how to find the domain that is also given in your syllabus 7A. So we will going to learn how to find the domain of such functions which are rational in nature. So 2 upon x plus 1. The function is 2 upon x plus 1. Now tell me one thing. I can put any x value here. Let's say for x is equal to 0, it will be 2 upon 0 plus 1. The y value will be 2. When x is equal to 1, it will be 2 upon 1 plus 1. The y is 1. When x is equal to 2, then it would be 2 upon 3, 2 plus 1, 3. So y value is 2 upon 3. When x is equal to 10, then it will be 2 upon 10 plus 1. So y value will be 2 upon 1. Similarly, we can put any negative value also. Let's x is equal to negative 5. So it will be 2 upon negative 5 plus 1. Negative 5 plus 1. So it will be 2 upon negative 4 minus 10. So it will be 2 upon minus 10 plus 1. So it will become 2 upon negative 9. Are you getting this? So we are getting every output for the given input. So there is no restriction to any x to get my y value. But it is not same for only one x value. So I was saying that you can see I wrote various x values here: minus 10, minus 5, 0, 1, 2, 10, and I was getting the y values for these x values. You can see the y values I am getting, right? So what is the domain? Domain is all real, I'm going to say all possible x value, all possible x values. So there is no problem in taking any x value here to get my y. I can take n number of x values and I can get y value for that. But there is only one x value for which my y value will not appear. How to find that x value for which my y value will not appear? So you can see the denominator is x plus 1. What happen if my denominator is 0? So 5 upon 0, will it define? You can ask from your calculator also. The result will be undefined. You can do any number divided by 0. Your calculator will either say math error or undefined. Are you getting this? So dividing any number from 0 would not possible. It means there is one x value for which my denominator will become 0, and I am not going to take that x value in my domain. And what is that x value? If I solve this domain, x plus 1 is equal to 0, because I won't want my denominator to be 0, so I'm solving it for the 0. What I'm getting? X is equal to negative 1. If I substitute here x is equal to negative 1, what is the result? Negative 1 plus 1. So it will be 2 upon 0. And 2 upon 0 is not defined. So only this x value here which makes my function undefined. Otherwise, all the x value is fine. So how do I write the domain of this function? I'll write domain as x such that x belongs to real number except x should not equal to -1. This is my domain. Are you getting this? Now it's become easier to find the domain of any such function which is rational. These functions are the rational functions. I'll solve my denominator for 0 and put that x value out. Put that x value out from the whole domain structure, which is real number. Now, can you tell me the domain of this A and B here? Yes, yes. You can see I was taking x anything here and I was getting the y values for it. But I'm only concerned with my denominator not to be 0. So I was solved the denominator for 0 and check for which value my denominator will become 0. So I found that if I put x is equal to -1 there, my denominator will become 0. So I'll not take -1 except all x value are okay. Yeah, so that is fine. So x is equal to 2 is defined here. You should just put out that x value for which your denominator is 0. So what do you do for that? What do you do what do you do for that? You will going to solve your denominator for 0. X plus 4 is equal to 0. So what is the x value? -4. -4 is that x value for which my this rational function will not define. If I put -4 there, the result will be 1 upon 0, which is undefined. So what I'm going to write? I'll write x such that x belongs to real number, x should not equal to -4 only. This is my domain. That will going to give you the y value. So that's what I'm telling you. X belongs to all real number, not 0. I'm including 0, 2, minus all the minus, all the pluses. But I will not accept only x is equal to -4 as my domain part. Only x is equal to -4 I will not accept my domain part. Other than that, all x value are fine for me. Clear? Similarly, for the b part, what you're going to do? You will solve the denominator for 0, that quadratic for the 0, and take out those x value from all real number. X is 2, but when I solve it for the 0, it is quadratic. I made two factors, x plus 5, x minus 1, that equal to 0. So when I solve x plus 5 for 0, my x would be minus 5. If I solve x minus 1 for 0, my x will be 1. So minus 5 and positive 1 are those x value which will not the part of my domain for this function. Did you solve this quadratic for why your answer is different then? Hmm. It's good that you recognize your mistake. All right. Did you get these all questions that we have done today? All right. So that was the part of your syllabus that you shared with me. Specifically, the questions were also mentioned. So I took all the questions from there. And I think we also done with this review set 17. That is function. Okay. Next time when we meet, we will take some other topic. We can discuss here. Okay. All right then. I think we are done for today. See you next weekend. Till then, take care.